Alright, this is 5-1A in Advanced Algebra 2, and we're taking a trip down memory lane from Algebra 1. You know, because you remember everything we taught you in Advanced Algebra 1. So here's a refresher of a product of powers. When you have some powers written with the same base, this is x cubed times x to the fourth. Both bases are x. Well, x cubed is really x times x here in green, and x to the fourth is really x times itself 4 times in a row, and you're just straight up multiplying them together. Well, you'd get x times x times x times x times x times x times x, which is x to the seventh. And instead of writing all this stuff down, the shortcut says if you've got a product of powers, product means multiply, of powers of the same base, you just add those exponents together and you get x to the seventh for your final answer. So here's some examples. We got some product of powers problems. When you want to do this, you just multiply numbers times numbers. See, this 2 is a coefficient and this 5 is a coefficient. They're not exponents, so you multiply numbers times numbers. 2 times 5 is 10. And then you take the same bases times each other. You take a's times a's, b's times b's, n times n's, and etc. And when you take n to the fourth times n to the fourth, since they have the same base, we use the product of powers, you get n to the eighth for a final answer right there. Over here, numbers times numbers in the form of coefficients, so 5 times 8, well, that's 40. And then we got b squared times b to the first. We really need to add those exponents together and get b cubed. And there's our final answer. And over here, we got coefficients of a 7 and a 10 and an 80. So we can punch all that in if we need be to. But 7 times 10 times 8, I'll let you punch that in. I don't need to do the whole thing for you. But you should get 560 when you do that. Then you take u's times u's and v's times v's, and you want to try to keep them in alphabetical order. You see, there are no u's involved with this one, but there are some u's here. So we've got u cubed and u to the first right here. So we'll multiply those together and get u to the fourth, because we added the exponents together. Then we'll do that with our v's. We got v to the third and v to the fifth. Right now that's v to the eighth if you add them together, plus 3 more would be v to the 11th. Try to keep your variables in alphabetical order. That's the proper form to do so. So let's do it again. Numbers times numbers, 80. X has come before y, so x to the first times x to the fifth, x to the sixth. And y's, you get y to the sixth, baby. And then over here, numbers times numbers, ooh, nasty, 5 times 1/2. No decimals, we don't roll like that. That'd be 5 halves. And then all this stuff that gives you a positive exponent, that stays upstairs. And anything with a negative exponent for a result, we'll kind of learn about that next class period. But when we multiply our x's together, because they come first alphabetically, you got x to the first times x to the second. That'd be x cubed, and that'll stay upstairs since you had a positive exponent. And when you multiply your y's together, you get a y to the negative third and a y to the positive third. If you add those exponents together, you get y to the 0th. Well, anything raised to the 0th power is 1. It's just a fact, and I'll explain it in our next section when we do quotients of powers, but anything raised to the 0th power will turn out to be 1. So it's kind of like those canceled each other out right there, and that's our final answer. We'll see more of the 0th power stuff when I get to the quotient of powers section. So it's just one of them facts you got to memorize, and it'll understand it here shortly. Now, next one, there are no coefficients, so we start in alphabetical order. A's, there's some a cubes. B's, you got b to the negative fourth here, and b to the sixth. Add those together and you get b squared, and that's a positive exponent, so that's good for us. And then c to the seventh and c to the negative seventh is c to the 0th, but anything to the 0th power turns out to be 1, so it's kind of like they cancel each other out. So now it's finally time to explain that 0th power stuff. First, here's the old quotient of powers tricks. It says if you got the same base right here, and quotient means you're doing a division problem of some powers of the same base. Well, it's really like x cubed over x squared is x times x times x over x times x. But you all know that when you have like an x over an x, those divide out to be 1, right? X over x is 1. Here's another x over x. They cancel out to be 1. So our final answer right here is just a plain old x. And if you could see, it's kind of like, I used to play, and I still play, a little game called Where Are There More? Well, wasn't there 3x's upstairs and 2x's downstairs? Where were there more x's? Upstairs in your fraction. And how many more were there? There was one more, so it's like you had x to the first left over. But if you see here on our next problem, when you got x cubed over x to the fifth, again, those cancel each other out, those cancel each other out, and those cancel each other out, because weren't there more x's downstairs? And how many x's are there more downstairs? Well, there's x times x. There's two more, so the x's have to stay downstairs in your denominator. And what's left upstairs? Well, there's a 1 up there, because it all got divided out to be a 1. It's your coefficients right here. You had 1 over 1x squared, which you don't put the 1 in front of that, but it has to be in your numerator. So just to kind of show you, if you had that negative exponent deal, well, it's kind of hard to explain until we learn about reciprocating the base next time, but if you had like x to the fifth over x to the fifth, it's like, where are there more? Well, there's the same amount. The real rule says you're supposed to subtract, you're supposed to subtract your exponents, but we get into a goofy situation with that, because if you subtract here, sure, you get x to the first. If you subtract here, you get x to the negative second. And you can't have negative exponents. So you're supposed to reciprocate your base, and the reciprocal of x is 1 over x, and that x has got to now have a positive exponent. It's the old reciprocate the base deal. Well, if you subtract your exponents here, you get x to the 0th, and anything to the 0th power is 1. It's because these all canceled each other out. It's just what we were doing on here. Cancel out, cancel out, cancel out, cancel out, cancel out. You get the same amount of x's upstairs as you do downstairs. It's all 1 right there. So, long story short, I like the little game called Where Are There More? Coefficients, though, cause us a problem. You have to just realize you need to reduce your coefficients as a fraction. This fraction right here is 3 over 2, which cannot reduce, so coefficients just come on down for the ride. You've got some r's upstairs, you've got some r's downstairs. There's 3 r's upstairs and 1 r downstairs. Where are there more? Well, there's more upstairs, and are there 2 more upstairs than there are downstairs? And you see, if you did the subtraction rule, you'd get 2 for an exponent, and since it's positive, it stays upstairs. On the next guy, coefficients again, 7/4. Can they reduce? No, 7/4 does not reduce. K's, where are there more K's? Well, there's more K's downstairs, because there's 2 upstairs and 3 downstairs, so there's more downstairs. How many more? Well, just 1 more, so I'll have a K to the first down there. If you did do the subtraction rule, you'd have 2 minus 3, and you'd get a negative 1. But a negative exponent means you got to make it change houses, because you got to reciprocate the base, and that's just too much work. It's like, wow, that is so confusing. Why don't we just do the Where Are There More game? So let's try that again. Slow her down a little bit here. Coefficients, 10 over 6. Well, 10 over 6 can reduce, because 2 goes into each one of those, so doesn't that reduce to 5/3? Then the p's, where are there more p's? Well, there's 4 upstairs and 1 downstairs. Well, there's more upstairs. How many more? There are 3 p's upstairs, so you get p cubed for your final answer there. Over here again, we start with a fraction bar, and we get our coefficients. 8/10. 8/10 can reduce, because 2 goes into each one of those. That becomes 4/5. And m's, where are there more m's? Well, there's the same amount. They cancel each other out. And if you was to subtract, you'd get m to the 0th, which that's 1. So they all just kind of canceled out, and you're just left for a final answer of 4/5 on this bad boy. Let's try this again. One thing, first move, coefficients. 14 over 6. They're both even, so reduce by a factor of 2, and you get 7/3. Then one variable at a time. X's, where are there more x's? There's more downstairs. How many more? 1. Y's, where are there more y's? There's more y's upstairs, and how many more? There are 3 more, since there's 7 upstairs and 4 downstairs. So let's try that one more time. Reduce your coefficients, if possible. You should get 6/5, because 2 goes into each one of those. Then stay in alphabetical order. X's, there's 4 x's upstairs and 8 x's downstairs. Where are there more? Downstairs. How many more? 4. And then y's, there's y's upstairs and downstairs, even though they weren't written in alphabetical order, and they have the same amount, so it's like they cancel each other out because it's y to the 0th, which is really just 1. So there's our final answer right there. And finally, if we turn the page, we get to some power situations. That's where you've got some power here in blue, x squared, and then that quantity is being raised to another power. It's a power of another power. Some people call it power to a power. A lot of people call it power of a power is what it's supposed to be called. But it means you're supposed to take this blue thing and take it times itself 3 times in a row. Well, I'll do that. X squared times x squared times x squared. And now it becomes a product of powers right here, to where all you do is add your exponents together, and 2 plus 2 plus 2 is 6. So this becomes x to the 6th. And the short way to get from there to there is to just multiply those exponents and get x to the 6th. So we just got to deal with these coefficients. That's the big part. We have to take 3 and actually cube it. Right? We are not taking 3 times 3 because 3 is not an exponent. 3 is a base. So 3 cubed is 27 because it's 3 times 3 times 3. Now, a squared also has to get cubed, so you need a squared times a squared times a squared. And since you're taking a power to another power, that would be multiplying the exponents and get a to the 6th right there. If we do that again, negative 2 is a coefficient. It needs to be cubed, so it means negative 2 times negative 2 times negative 2. Well, that would be negative 8 if you cube negative 2. And since that's an odd power, yes, that can come out to be a negative number. It's any even power that you raise something to will always come out positive. Then x's have to be cubed, so x to the 4th to the 3rd would be x to the 12th because you multiply the exponents, y to the 15th. And this is z to the 1st. It's got to get cubed, so that becomes z to the 3rd when you multiply those exponents together. And on number 15, they got all of this junk right here raised to the 0th power. Well, the whole red thing is going to get raised to the 0th. So you take 5 to the 0th, which is 1, m to the 0th, which is 1, n to the 3rd to the 0th, which is 1. It all shoots out to be 1 because anything raised to the 0th power turns out to be 1, and the whole red thing was being raised to the 0th power. So that was an easy one. Me likes those. Anything raised to the 0th power is 1. These next few, you should follow the order of operations and simplify what's in the parentheses first. In the parentheses, we can clean that up. I kind of messed that up there, but we can take 3x squared times 2x squared. 3 times 2 is 6. X squared times x squared is x to the 4th, and that all has to get squared. All I did was take this green information, which is inside the parentheses, and simplify it. Now, I square the result in here. 6 has to get squared because it's a coefficient. That'd be 36. X to the 4th needs to get squared, and since that's a power to another power, that would be x to the 8th situation. Again, in here, we need to simplify what's in the parentheses. Negative 2 times 4 is a negative 8. P squared times p is p cubed, and all of that is getting squared. So, to square this, negative 8 squared, it's going to turn out to be a positive number. Anything raised to an even exponent will come out positive, so that would be 64. And p cubed to the 2nd, multiply the exponents, and get p to the 6th. Since we had more than one situation, we should box our answer. And finally here, why don't you pause the video and try number 18 for me real quick. Should have simplified what's in there first and got a negative 12. And then y to the 4th times y to the negative 4th is y to the 0th, which I'm not even going to write because that's 1. It's all got to get squared, and you should just get 144 out of that situation. It turns out positive because anything to an even exponent will turn out to be positive. So there's 18 examples for you. Your homework is to finish this, do the 1 through 21. Let us know if you have any questions. Have a good one.